Hello, Assalamu alaikum. Welcome to the channel, The Twins Academy. We were discussing the topical MCQs of O levels and IGCSE related with the topic nuclear physics, and the subtopic was detection of radiation on the basis of their properties of characteristics. So it's the part B of that episode. So let's solve the remaining MCQs. Okay, Ji. So now in this question, the diagram shows the apparatus used in the experiment in which barriers of various materials are. So barriers means that we are using absorbers of different materials are placed in turn between different radioactive sources and a detector. So this was the source and this was the detector, and these were the barriers of different materials or absorbers. Okay, Ji. The count rate recorded by detectors for 4 sources. Okay. Which source emits alpha particles only? Okay. Now we are requiring to detect the emission of alpha particles, and we know that alpha particles can be stopped by paper only. So alpha particles are stopped by paper only. So paper for alpha and aluminium for beta and lead for gamma. Okay. Starting reading 200, 200, no barrier. Okay. After placing paper, is there any change? No. So it's mean alpha were not present. 200 and change? Yes. It's mean alpha can be present. Okay. 1200 to 600. So it's mean after placing paper, reading has changed. Yes. Alpha can be present. 1200, but no change after placing paper. It's mean two options are discarded, A and D. Now out of B and C, we have to check. Okay. After placing aluminum, is there any change in the reading? No. After placing lead, is there any change in the reading? No. So it's mean that option B is the correct answer. Why? Because after placing aluminum in option C, the reading has changed from 600 to 200. So it's mean that now beta particles were present. So option B was the correct answer. Okay, so in this question, the important thing is that there is a distance between detector and radioactive source, and this distance is equal to 10 centimeter. Okay, so when distance is 10 centimeter, so it's mean alpha particles cannot be detected because approximately range of alpha particles in air is approximately, you can say, 7 to 8 centimeter. In some books it is written up till 5 to 6 centimeter as well. So definitely at a distance of 10 centimeter between radioactive source and detector, alpha particles cannot be present. So alpha particles are absent. Okay. So it's mean option A cannot be possible. Now option B, C and D. Now what we will do, we will go through the results. Okay. Without magnetic field, the reading was 4500. Okay. Now with magnetic field, we know that alpha are positively charged particles, beta are negatively charged particle, and gamma rays are neutral. Alpha were absent. Now since beta particles are charged particles, so they show deflection. But after deflection, reading is not going to be 0 or equals to background radiation. So it's mean out of 4500, 2500 representing the beta particle. And in the presence of magnetic field, they have deviated or they have deflected. And these remaining values showing the presence of gamma rays. So if this was equal to background radiation, then only we select option B. Now since beta is deviated but still, and gamma rays always travel straight, either in the presence of electric field or in the presence of magnetic field. Why? Because they are neutral rays. So which option is correct? Option C is the correct answer. The next question. Okay, Ji. Which is the correct comparison of penetrating power, ionization, and penetration? They are inversely proportional to each other. So for ionization of alpha was greater than beta, ionization of beta was greater than gamma, and now the penetration will be reversed. Penetration of gamma is larger than the penetration of beta, and penetration of beta is larger than the penetration of alpha. Okay, now this question is related with penetrating power and ionizing power. Okay, G. Alpha and gamma. So let's check the ionization. So ionization of alpha is greater, because it is required in the column greater ionizing power. So it's mean option A and option C can be possible. And penetrating power, since alpha has largest ionizing power, so they have least penetrating power, and gamma has least ionization, so they have largest penetration power. So greater penetrating power, gamma. So option C is the correct answer. Which statement is true for all three type of radio active emission, alpha, beta, and gamma? Okay, they are completely absorbed by thin aluminum sheet. No, beta can be only absorbed by thin aluminum sheet. They are deflected by electric field. Gamma particles or gamma rays are neutral, so they always travel straight in the presence of electric as well as magnetic field. They emit light. No. They ionizes the gases. Yes. So all three type of radiations ionizes the gases. Okay, in this question, radioactive source and detector, they are placed at a distance of 30 centimeter. Okay, the experimenter moves the paper between the source and the detector. There is no difference in the count rate. So it's mean after placing the paper sheet, the count rate remains the same. Why is this? Okay, they have given in the question that radioactive source is emitting the alpha particles. Okay, paper doesn't absorb alpha particle. Wrong. Paper always stops or absorb the alpha particles. The count rate due to background radiation is too high. Since there is no difference in the count rate in the presence of radioactive source, so background radiation is never ever supposed to be too much high. The radioactive source is too far from the detector. Okay, since it is emitting alpha particles and the distance was 30 centimeters, so alpha particles cannot be detected at a distance of 10 centimeter. The source emits beta particle and alpha particles. If they are emitting alpha and beta particles, reading should change. So this option is wrong. And since after placing the paper, they can pass through the paper as well. So option C is the correct answer. The source is too far away from the detector. Which ray travels straight? Alpha are positively charged particles, beta are negatively, and gamma neutral. So these two radiations shows deflection in electric and magnetic field, and gamma rays travel straight. Okay, the student investigate radioactive source that emits only alpha particles without any source. The detector was showing a low reading. Okay, the source and the thick cardboard are placed near the detector. Okay, so this is a thick cardboard or plastic sheet like this. What is the reading on the detector? Reading was already low. Now after placing paper, alpha particles cannot be detected by the detector. So it's mean that now this reading is related with background reading. Now let's check. Detector reading 0. Now after placing even paper, already it was showing, because what is written without any source. So without any source mean that background radiation. So these two options cannot be possible. So now we will figure out this. Low radiation. Some alpha particles pass through cardboard. Not possible. Alpha particles can be stopped by cardboard. So option A is the correct answer. Okay. The diagram shows radioactive emissions that passes through a piece of plastic and the metal. Okay. Of the same thickness. Which type of radioactive emission can be distinguished between plastic and metal? Okay. From plastic, alpha are not supposed to be passed. So we cannot differentiate between alpha particles. Okay. From metal. Now in this diagram and in this diagram, there is a difference between these two. Means to say, between beta particles. Gamma rays are passing through the plastic sheet as well as gamma rays are passing through the metal sheet. So only the difference between these two. So it's mean that plastic and metal sheet is used to distinguish between beta particles only. Three type of radiation emitted by the unstable nuclei are helium nuclei, shorter wavelength, and electrons. Helium nuclei means alpha, shorter wavelengths mean higher frequency gamma, electrons means beta. Helium nuclei, alpha, option A, straight wave, option A, electromagnetic waves gamma, electrons beta, so option A is the correct answer. So you have to memorize their properties or characteristics. Which row states the nature and range of the beta particles? Okay, beta particles are negatively charged particle and electrons, and range. Okay, so their range is less than the range of gamma rays. So more than alpha rays and less than gamma rays. So it's mean this belongs to approximately to the alpha rays, and for beta particles, their range between 10 to 100 centimeters. So option D is the correct answer. Which particle has smallest mass? Obviously, electron is the lightest particle. So electron or beta particle has smallest mass. People working with radioactive materials use a photographic film badge. It is a detector covered in paper. This is important thing. The badge is used to monitor the level of their exposure to radiation. Which radiation is detected? Since paper is there, so paper stops alpha radiation. So this option is not possible. Okay. Now through paper, beta and gamma can easily pass through. So option C is the correct answer. So the last question, which states the three type of radiation emitted by radioactive isotopes in order for their ionizing effect from highest to lowest. So alpha has highest, beta has lower, and gamma has least. So option is the correct answer. So best of luck to all of you. So if there is any query, please send in comments. Assalamu alaikum and take care.